Hi, in this video we're going to be looking at completing the square. The question reads, find the minimum value of x squared minus 4x minus 5 by completing the square. The first thing we need to do is make the coefficient of x squared 1. In this case it is already 1, so we don't have to worry about that. Next we're going to create some space. I'm going to move minus 5 a little so that I can add in another term. So we want to add half, which means divide by 2, the coefficient of x all squared. So the coefficient of x is minus 4. And if we half minus 4, we will get negative 2. You square negative 2, you're going to get positive 4. So once again, half of 4 is 2. And we square that, it's positive 4. Remember, you square negative, it must be a plus. Now you'll notice, compared to the original question, we added 4 in. So to cancel this effect off, we're going to subtract that 4, which I've done. So 4 minus 4, it cancels each other off. So moving on, the first 3 terms is a perfect square trinomial. We want to factorize that. A quick way to factorize that, square root of x squared is x, square root of 4 is 2, and your negative comes to the bottom, and we're moving our square to the outside of the bracket. So we have a perfect square trinomial, which is factorized into x minus 2 all squared. Minus 5 minus 4 minus 9. So if we look at the coefficient of x squared, it is 1, which gives us a happy face, a happy parabola. And a happy parabola is one that has a minimum value. So our minimum value is at the point, change your sign, 2 minus 9. And the actual minimum value is the y value, which is negative 9. Please note, we're going to use this later in number patterns. And the application in number patterns is that the minimum value would be at term number 2. So this 2 will represent the term number which has a minimum value. Moving on. The question says, find the minimum value of minus 2x squared plus 3x plus 6 by completing the square. So we want to make the coefficient of x squared 1. To do that, we're going to take out minus 2 as a common factor, which means divide each term by minus 2. Minus 2 divided by minus 2 is 1. 3 divided by minus 2 is negative 3 over 2. 6 over minus 2 is minus 3. Next we're going to create some space. So I moved minus 3, which allows me to add and subtract a term. So what is the rule of adding and subtracting the term we're looking for? It's the coefficient of x, which is minus 3 over 2. Divide that by 2, which is minus 3 over 4, or half of that. And then we're going to square it. So we're taking 3 over 4 and we're going to square this. Remember, a negative squared will be positive. And that gives us 9 over 16. The rule says plus and minus, so we're going to subtract it. Next, we're going to take the first 3 terms, which will form a perfect square trinomial. And we're going to factorize that. So remember, our minus 2 is going to come down. Square root of x squared, x. Square root of 9, 3. Square root of 16, 4. Sign from the middle, negative. And we place our square outside the bracket. Minus 3 minus 9 over 16 is minus 3 and 9 over 16. Next, we're going to take this minus 2 and distribute it. We're going to multiply it into the first term, and we take the minus 2 and multiply it to the second term. So if we do that, we get minus 2 into x minus 3 over 4 all squared. Negative times negative is positive. 2 times 3 and over 9 over 16 will give us 7.5. So if we look at the coefficient of x squared, it's negative, which means we're going to have a sad parabola. And we know a sad parabola has a maximum value. That's the highest point. So we know the maximum value will be at point. Change your sign. 3 over 4, 7.5. And that tells us that the maximum value will be 7.5. In terms of applying this to number patterns, we can say that 3 over 4, and in this case it will not work because you can't have a term called 3 over 4. It has to be a natural number. But this normally will refer to the term position. Thank you.